Alright guys, so today we're going to be doing section 4.5, solving equation using the Annihilator approach. So what I have here is y prime plus 5y equal negative 180x squared. In order to solve this problem, we're going to be doing it in two steps. First, we're going to find yc, known as the complementary solution, and then we'll find yp. Alright, before we start, I just want to let you know the formula that I'm going to be using is going to be y equal yc plus yp, also known as the homogeneous plus the non-homogeneous. So first what we want to do is that we're going to set y prime plus 5y equal 0. So we would do that. There's another way we can write it as m squared plus 5 equals 0. If we solve that, we would get m equal plus or minus square root of 5, or m equals 0 plus or minus I square root of 5. In this case, we don't have any alpha, but we do have a beta of square root of 5. If we write this out, it will be c1 cosine of square root of 5x plus c squared sine of square root of 5x. Next, what we want to do is that we want to find the y of p. In this case, this is where we will look at the right hand side of the solution, which is negative 180x squared. So in this case, it's a quadratic times e to the x, as we can see right over here. So before we start, we wanted to write out the format of how we are going to take the derivative. So the format is going to be yp equal ax squared plus bx plus c times e to the 5x. In this case, in order to find y of p, we have to take the derivative of this equation twice. So what we're going to be doing, so when I take the derivative, I will get 2ax plus b times e to the 5x plus ax squared plus bx plus c times e to the 5x times 5. To clean this up a little bit, we will get 2ax plus b times e to the 5x plus 5 times ax squared plus bx plus c times e to the 5x. Since we got our y prime, we have to take the equation one more time. So if we do that, we will get 2a times e to the 5x plus 2ax plus b times e to the 5x times 5. And then plus 5 times 2a plus b times e to the 5x plus 5 times ax squared plus bx plus c times e to the 5x times 5. This is very big, so what we could do, we could clean this out a little bit. If we clean it, we would get 2 ae to the 5x plus 10 times 2ax plus b times e to the 5x plus 25 times ax squared plus bx plus c times e to the 5x. Now what we want to do is that we want to plug this back into our differential equation. So from this equation right over here, so if we plug that back in, what we want to do is to find the coefficient for yp. So the way that we do that is that we find the highest term. So our highest term in this case would be x squared e to the 5x term, and then the next one will be x e to the 5x, and then lastly it will be e to the 5x. The way I find the terms on the first for the first one would be, if you look at this third term right over here, 30ax squared e to the 5x matches the terms that we're looking for. So we'll solve for a. So 30a, we'll set it equal to negative 180 because there's a squared right over there, e to the 5x. So if you solve for a, it will be a equals to negative 6. Our next term will be x e to the 5x, which we have some right over here, 10ax e to the 5x. So we can write down over here as 20a. If you multiply 2 times 10, that would be 20a. Our next term will be in our third term over here, so 30bx e to the 5x. And we set this term equal to 0. So now we have now we solve for this equation over here. We know that a is equal to -6, so we can plug a for -6, which will get -120 plus 30b equal to 0. In order to solve for b, we'll add 120 over to the right-hand side, which will get 30b equal to 120, which will get b equal 4. Lastly, we'll find the third term, e to the 5x. For this one, we have a couple. So if you look right up here, we have a term right over there. So 2a equal to 5x. And then we also have a term right over here, 10ax equal to 5x. That's what we're looking for. So that's why we have 10, oh no, not my bad, 10b, my bad guys. 10b times e to the 5x, which is why we have it over here. Lastly, our last term where we for the e to the 5x, it will be found in the third one. So you see 30c e to the 5x. So that's why we have 30c. For this equation, to solve this equation, we know a couple terms already. We know our a, we know our b. Our a is -6, our b is 4, so we plug those in. That's why we get -12 plus 40 plus 30c equals c. So if we add -12 plus 40, we'll get 28 plus 30c equals 0. C will equal to -28 over 30. To clean this up a little bit, we'll get -14 over 15. So our y of p we're going to get is -6x squared. Since we all have our terms here, we can put it into yp. So -6x squared plus 4x minus 14 out of 15 times e to the 5x. And our final equation would be, our final solution, not final equation, will be y equals c1 cosine square root 5x plus c2 sine square root 5x plus parenthesis -6x squared plus 4x minus 14 over 15 times e to the 5x. You can clean this up a little bit, but this is also an acceptable answer. Thank you for listening to me.